Today we will find factors using divisibility as well as find the prime factorization of numbers. A number is divisible by another number if the quotient is a whole number with no remainder. So example, 30 divided by 5 is 6, so 6 would be the quotient. Here are some quick divisibility rules if you want to find out if a number is divisible by 7. Then you do this, cross off the last digit, double it, subtract. If the new number is divisible by 7, then the original number is divisible by 7, and so on and so forth. So let's look at 462. Is 462 divisible by 2? Yes, it's an even number. It's divisible by 2. By 3? Yes, it is divisible by 3. If you add all the numbers together, they make another number that's divisible by 3. By 4? No, it is not. By 5? No, it does not end in 0 or 5. What about 540? Is it divisible by 5? Yes, it is. Is it divisible by 6? Yes, it is. And is it divisible by 9? Yes. And 10? Yes. Numbers that are divided by more than just one in itself are composite numbers, where prime numbers, the only numbers it's divisible by are itself and 1. So 13 would be prime, but 0 and 1 are not prime, and they're not composite numbers. Examples, is 23 prime or composite? Prime, it's only divisible by 1 and 23. Is 48 prime or composite? Composite, it's divisible by 2, it's divisible by 4, it's divisible by more than just 1 in itself. Is 31 prime or composite? It is prime, it is only divisible by 1 and itself. So whole numbers that are multiplied to find a product are called factors, and a number is divisible by its factors. So here 2 times 3 equals 6, 2 and 3 are the factors, 6 is divisible by both 2 and 3. So let's say we're given a number and we want to list all the factors. The first two factors we should come up with are 1 and the number. It's divisible by 1 and itself. Then see if it's divisible by 2. It is. 2 times 8 is 16. It's not divisible by 3. It is divisible by 4. 4 times itself. It's not divisible by 5. It's not divisible by 6. It's not divisible by 7. So now we have 8 and 2 again. You don't have to go any further because we already have 8 and 2 up here, even though they're in a different order. So once you start repeating a product of the same numbers, then you can stop. So the factors of 16 are 1, 2, 4, 8, and 16. Notice that even though it's 4 times 4, I don't have to list 4 more than once. Just one of each number. 1, 2, 4, 8, and 16. The prime factorization of a number is a number written as a product of its prime factors. And let me show you what that looks like. Okay, let's say we're trying to find the prime factorization of 24. The way we want to go about finding a prime factorization is by making a factor tree. So let's try to factor this out. 1 and 24 we can do, but it's just going to get us 24 again to factor, so it won't help us that much. And 1 is not a prime number anyway, so that wouldn't help us with the prime factorization. So let's think about 2. Yes, this is divisible by 2. That would be 2 times 12. Now 2 is a prime number, so we can stop here. But 12 is not a prime number, so we need to keep going. 12 is the same as saying 2 times 6. 2 is a prime number, so we can stop the tree, this branch here. But 6 is not a prime number, so we need to keep going. 6 is divisible by 2 as well. That's 2 times 3. Again, 2 is a prime number, and 3 is a prime number. So now we have no more composite numbers to break down. We only have prime numbers. So we have factored this down as far as we can. And the way you would write this for the prime factorization would be 24 equals 2 times 2 times 2 times 3. Alright, or you could even simplify it a little bit more. We have 3 2's, and if you remember, that's the same as writing 2 cubed times 3. Alright, let's look at another one here. Oops. Alright. Let's look at 15. We want to do prime factorization of 15. Well, 15 isn't divisible by 2, but it is divisible by 3. And that's 3 times 5. Alright. So, 3's prime, can't go any further. 5's prime, can't go any further. So sometimes these prime factorizations are just that easy. 15 equals 3 times 5. Alright, what if we had 20? 20 is divisible by 2. And then 2 times 10 makes 20. Choose prime. 10 is not. 10 is the same as 2 times 5. Choose prime. 5 is not. So 20 equals 2 times 2 times 5. Or 2 squared times 5. If you would like more practice on this or more examples, I'll go over some in class. Starting Monday, you can head into the Zoom room before school or email me to set up a lunch tutoring session, and we can definitely go over some more examples. I can help you through wherever you're getting stuck, and we can help you be successful. I'll see you in Zoom.